I'm Yolande Poirier from Oracle Developer Network, and my guest today at Devox in Belgium is Alexei. Alexei, hi.
Hey.
How are you doing?
I'm good, thank you.
Good. So you have a talk about Shenandoah, which is a garbage collector.
That's right.
So why do we need a second garbage collector?
Oh, okay. I'm going to talk about this on my talk. So the gist of it is we are progressing from fully stop-the-world collector to fully concurrent collectors. G1 and CMS are kind of halfway there. There is the second part, which is actual relocation of the object and the updating the heap references after you did that. Current OpenGTK collectors do that in Stop the World. Shenandoah does it concurrently. All pauses, because it solves most of the problems that are there. It does it concurrently.
Okay. So why is that important? Or when is it important?
Right.
I mean, like a kind of a...
There are two overheads are dependent on the amount of alive objects in the heap, which are proportional to the heap usually. So if you are looking into the real-world deployments when you have multi-GC technology to do nicely in those heaps. And the second part is that when you realize that the garbage collection overheads are after honoring human units, like you have the metric that you don't want the pause time larger than 100 milliseconds, for instance. That means if you run slow hardware, it gets interestingly on your desktop, which has the pause times of 10 milliseconds, and then you run on the embedded device, which is 100 times slower, and for the same amount of work, you now have a second. I think it's mostly about low latency, which means larger heaps or slower hardware.
Okay. So, and so in your...
Yeah, we prefer not to talk about Shenandoah itself, because if you look at innovation and everything there is brand new, it's not like that. It's usually the incremental improvements in the technology. And so to understand what step Shenandoah does, we are explaining what current GCs do and why they do this particular way, and why it's complicated to do what Shenandoah does.
Well, I mean, it's for large applications, but more specifically, like who today is not looking at this technology and might actually be interested in it?
I think that the people who are to understand that there is the latency throughput trade-off going on, so you cannot have low latency and high throughput at the same time. There's a kind of counterintuitive goals there. So most people who are running GC poses, but they want another 30%, say, or 20% throughput improvement on top of that. So in my mind, there higher latency. You have Shenandoah, which has low latency, but more throughput overhead. And you have J1 and CMS, which kind of in the middle, try to balance between these two. It might as well be that your application is actually running fine without Shenandoah, and we are happy that you have that application. Some of our applications do not run fine.
Where do you find more information about
Shenandoah? We have a wiki page, which is, I think, the first Google hit when you Google for Shenandoah Java, gives you the wiki page on OpenGTK JavaNet. You have all the information there, where to get the builds, how to tune it, what it is.
I should have started that way, but
okay.
That's okay. Well, thank you. And so your talk is actually this afternoon as well. Right?
Yes.
We'll see it online.
Right.
So
thank you.
Thank you.
Okay. All right. Shenandoah, yeah. Yes, the spelling differs. I call it Shenandoah. Some of the locals call it Shenandoah, because the Shenandoah Park and Shenandoah Valley is there. So just try something.
Okay. Okay. Sorry. So basically, we're going to do the exact same interview again.
Okay.
Either side. That feels better. Yeah.
That's good.
Is that okay? It touches my face a little bit. I'm aware that I'm doing Oh, yeah, thanks, Alex. Okay, I'll just stay me who has the constraint.
All right.
Shenandoah.
Yeah.
Thank you very much for agreeing to do the interview. Well, most of you will know him very well as performance expert. And so you're giving a talk about a new garbage collection that you want people to adopt.
Yes.
Shenandoah.
Yeah, that's right. We are developing that exhibits GC poses that people do not like. One of the is that there is the shift from the completely stop the world GCs to more concurrent ones. J1, for instance, is the good stepping stone to that, and it does just actually relocating the objects and fixing the heap pointers after you relocated it. And this is where Shenandoah comes in. It solves that second part on the heap size anymore. They are dependent on the root set size, but that's usually much, much smaller than the active heap size. And so you are able to put in every scenario.
Okay, so we have much, much smaller garbage collections.
Run, but application is not stopped at that point. So it might run slower because it's still the same hardware, and GC also needs cycles to run to its senses and gives up some of the heap. It's not like that. Most heavyweight phases are concurrent.
And where is it in development? Is it ready to go?
Targeting JDK 10 as it is now. Probably with the release LTSs, we will target what's it called right now, Java 11, I guess.
Yep.
Incepted, and we helped develop the GC interface, which makes plugging in new GCs to the hotspot easy. After that is in hotspot, plugging in Shenandoah would be also distribute downstream builds. And our downstream builds in Fedora and RHEL today include Shenandoah. So if you have Fedora on your many derivatives from RHEL are also including Shenandoah in this regard. For example, Amazon Linux, if you install Java 8, have Shenandoah there. So it's not product ready yet, but it is in beta quality. So if you are, if you've tried right now without messing with turbos or something like that, it might come with your OpenJDK build right now on your system.
Thank you very much. Yeah, I thought you don't want you to get tired of answering.